Hi, my name is Deb Brunel. I'm the Principal Solution Architect at Red Hat's DoD team, and today I would like to demonstrate how multiple Red Hat cloud products can be integrated together to create a software-defined cloud computing environment. There are two main advantages to this approach, the first being efficiency. So this deployment is going to take a fraction of the amount of time to complete compared to the manual processes that a system administrator may have to go through. We accomplish this by using APIs and other automated means to automatically configure the resources that need to be deployed. And that leads us to the second advantage, which is consistency. Since we're doing the deployment programmatically through the use of APIs, we can ensure that security settings are consistent across the entire environment and across each deployment. We can make sure that configuration file settings are also consistent across the entire environment. And when you have consistency across an environment, especially around security rules, you can help ensure the security of your cloud environment. Our demonstration today consists of 5 major steps. I'm going to go over those now because the rest of the demo moves rather quickly. The first step is that a user logs into the CloudForms self-service catalog. Once he logs in catalog, he fills out a form to request a pool of OpenStack resources to be deployed, or a pool of resources be deployed in OpenStack rather. Once he clicks submit and he approves the order in the shopping cart, step 2 begins, which is CloudForms automation workflow deploying the actual requested resources. This includes a virtual machine that is configured to run a Node.js application. It just has the binaries in there to run the application. It doesn't actually have any application code in there yet. There's some advantages there around limiting how many templates you have available and that you'd have to keep patched within your image library. Once the virtual machine and the other OpenStack resources are deployed, the orchestration engine, CloudForms, is notified that the deployment is complete. Next, the third step happens, which is CloudForms registering the virtual machine as a new workload in an Ansible inventory, and then scheduling a playbook to be run that configures the application. Step 4 is Ansible creating or completing the configuration of the application by logging in securely into the new VM, configuring the application itself, configuring the service that starts and stops the application, as well as firewall rules within the virtual machine itself. So we have what are essentially firewall rules of two different layers. One is inside the virtual machine, and the other one is at the infrastructure layer. And then finally, step 5 takes place, which is the user being notified via email that the deployment is complete. Let's go ahead and log into the Red Hat CloudForms management engine portal now. I'm going to log in as a user called admin. And once I get logged in, I'm going to come to the service catalog and click the button for New OpenStack Project. I'm going to call this project Deployment Demo, and I'm going to give the username the name of Shadowman, and I will give him an appropriate password. For email address, I'm going to use my own email so that I can get notified when the deployment is complete. I'm going to paste in an SSH key in case Shadowman ever needed to access the virtual machine. Once it's deployed, he can do it using an SSH key in a very secure fashion. Next, I'm going to come over to this Network Information tab where I get to provide the virtual machine name. We'll call this Demo VM. We have to give a router name, so we'll call it Demo Router. I'm not going to change the subnet or the subnet gateway, but I will create a demo network. That's the internal network that the virtual machine is going to connect to. If this was an actual OpenStack project environment that was being set up, I may want to adjust the quota, and determine how much storage I would need, how many virtual CPUs for my entire project. That could consist of multiple virtual machines. For now, I'm going to leave this alone, and I'm going to click the button to add it to my shopping cart. Next, I'll click my shopping cart icon and confirm that the order can be submitted. Once that's happened, inside of CloudForms, the automation should start taking place. So I'm going to log back into CloudForms, now going through the administrative portal. Again, logging in as the administrator. And this time when I get logged in, I'm going to go over here and click on Requests. The request I just submitted is this one that is pending on the top. You can see it has been auto approved, and when I click reload, you can see that it's going through and creating resources now within OpenStack. Right now it's actually creating the Shadowman user. So you can set up the workloads inside of CloudForms to not be auto approved, to require that somebody approve that. I just have everything set up right now to be auto approved. So the status has changed now. Shadowman is logged into OpenStack to create a VM. So let's go ahead and log into OpenStack ourselves as the Shadowman user. This is an older version of OpenStack platform. This is version 7 from Red Hat. But it's a little bit old, but it still works fine for this demo. Okay, so when I log in, I can see that I have instances and virtual CPUs and virtual RAM all being used. What I want to start with is showing the access and security. We talked about creating the security group rules as part of the deployment. So I'm going to click on the security group rules, manage rules, and we can see that ICMP rules have been created along with the rule to allow SSH, HTTP traffic, and HTTPS traffic. So I can, through automation, limit the type of traffic that can get into this environment or to that virtual machine. Next, I'm going to click on network and network topology and show the network that's been created. And again, this is all through API calls. So here's the demo router that we specified we wanted created, as well as the demo network. And we see our demo VM is already up and running. So let's click on compute and instances. And we can see that our demo VM is up and running. It's in a running state. And its IP address is 192.168.100.102. So that's the IP address right there. Next, we're going to click and log into Ansible Tower. If you remember from the 5-step discussion before, Ansible Tower is responsible for the configuration of the service and the virtual machine itself. So I'm logged in. I can see I'm in my inventory screen. I'm looking at the OpenStack demo inventory. And I can see that same IP address as being a registered host within my system. When I click on jobs, I can see that there's a job running called install Twitter heat map, which is how I described our application. And the work here is also already done. So you can see Ansible went and made a directory for the server content. It copied the server content over to the server, or the application content to the server. It grabbed the Node.js service file, enable the Node.js service so it would start up automatically if the virtual machine were to ever reboot. And then it changes the firewall settings to allow HTTP traffic and restarts the firewall. So the play ended successfully. Everything worked well. If I come over to my email tab, I can see I've received an email about project provisioning. Here are the quotas that I did not change. But I also have a link down here to my application. Once I click on the link, I should see a Twitter heat map appear. And what it's doing is it's plotting all the geographically tagged tweets in near real time on a worldwide map. So we can see where there's a lot of traffic. This is kind of equivalent to any kind of sensor traffic that you might see. It could be movement along a fault line. It could be movement across a field or through a city, or maybe fire alarm sensors going off in several buildings that are owned throughout a large area. But essentially people with their cell phones and who are sending out Twitter messages are really just sensors. They're detecting something and sending out a message about it. So that concludes our demo. Hopefully you guys got an understanding of how a software-defined cloud computing environment is a great way of gaining efficiency and consistency within your environment. If you have any questions, please let me know. If not, thanks for watching the video.